Okay, folks, I think we're going to get started now. So hello and welcome to Still Moon Arts Public Talk Series. Through this series, we aim to shed light on Still Creek through local projects. Today, we're joined by the Road Salt and Pacific Salmon Success Project. My name is Connolly, and I am the Still Moon Stewardship Coordinator. And if you're new to our organization, we facilitate arts and stewardship projects in the Renfrew-Collingwood neighborhood, and our goal is to create a vibrant and connected community through these events. Today and every day, Still Moon operates on the lands of the Musqueam, Squamish, and Tsleil-Waututh peoples. We hope to honor them through our work and really appreciate traditional knowledge in what we do in stewardship and arts. And a quick thank you to our funders at Habitat Trust Conservation Foundation, Vancouver's Greenest City Grant, and the TD Friends of the Environment Foundation for making this event possible. So today we're joined by 3 members of the Road Salt and Pacific Salmon Success Project. We'll hear first from Nikki Kroetsch, who works for DFO as the Community Engagement Coordinator for the project. I'll speak briefly about Still Moon's streamkeeping activities, and then we'll hear from 2 UBC master's students, Carly Winter and Claire Kilgore. Carly studies the impacts of road salt on salmon development, and Claire studies how peaks of salt in streams impact salmon sustainability. Sweet. Okay, I'll hand it off to Nikki.
Thanks, Molly. Hi, you guys. So pleased to be here today. As Connolly mentioned, my name's Nikki. I'm the Community Engagement Coordinator at the DFO Pacific Science Enterprise Center, which is a research lab in West Vancouver. So part of my role, I'm very fortunate enough to get to support this project and all the groups that are participating in it. And so my job today is to start us off about just a little introduction and overview of the project itself. So I'm going to very briefly, just to warm us up, just give a brief overview of why we care about salmon. I'm sure 99% of you here know all the reasons why, but we're going to touch on that just very briefly. Then we're going to go on to why we care about road salt. I will briefly cover why we choose to monitor conductivity as opposed to salt in the water. And then I'll give a bit of an overview about the project, how it got started, what we're kind of trying to hope to achieve, and then I'll pass it over to Connolly. So this is for you guys to answer. Why do we care about salmon? Just yell it out.
Jason.
Absolutely. You can actually do next slide, Connolly. First and foremost. Why else do we care about salmon?
Ecosystem, they're a big monitor of ecosystem health.
Yes, absolutely. We need healthy streams and healthy, clean water in order for salmon to thrive. Why else are they important?
Brings minerals from the ocean.
Yes. Okay, I was hoping someone would say that one. Yeah, for those who don't know, they're really important for nutrient cycling. So salmon are born in freshwater creeks, but they swim downstream pretty quickly. Some of them right away, some of them after about a year, but they do most of their growing in the ocean. And so all of the nutrients that are in the salmon's body are from the ocean. But then they swim upstream and they die back in those freshwater ecosystems. And all the animals that choose to eat them, things like bears and coyotes and eagles and stuff like that, will drag those bodies into the forest to go snack in safety. And then when those salmon carcasses decompose, they fertilize the forest. And so you've got the forest contributing nutrients that travel downstream to the ocean, and the salmon bring them back. So if we lose salmon, not only do we lose tasty things like sushi, we also kind of affect that cycle of nutrient cycling. Spoiler.
Yeah, cultural benefits. They're so important to all the First Nations.
So important, yeah. Indigenous and non-Indigenous communities. Absolutely. So huge cultural value. The economy too, like not just people that catch the fish, you don't immediately catch a fish and then eat it. For the most part, you catch it, it gets transported, it gets packaged and processed, sometimes canned, then it's sold in either a grocery store or a restaurant. And every single step of that process, money is exchanged. So even if we have more of an environmental focus, we also can't ignore the fact that salmon play a huge role in our economy. And the salmon are cool. The more you learn about them, the more you just realize that they're an incredible species, and it just makes you kind of love fish. Even if you're not inherently a fish nerd, the more you learn about salmon, you become one. Slide, please. Okay, so switching gears, why do we care about road salt? Or what do we know about road salt? So why do we use road salt, first and foremost?
So the ice.
So if you want to look at the technical side of it, road salt lowers the freezing point of water. So water normally freezes at 0 degrees, but if you add salt onto a surface, it can get to be about negative 10 degrees before that water starts to freeze, which for here, we don't usually dip below that, so it's very, very effective in keeping our roads and sidewalks not super slippery. So simplified, we use it for public safety reasons. Who applies road salt?
The city.
The city, yeah. Who else?
And neighbors.
Neighbors,
Residents.
residents, businesses. Honestly, pretty much whoever wants to. Like, you can just go and buy a bag of salt at Canadian Tire or whatever other store sells it, and you can apply it wherever you like. How much salt gets applied to roads in your city each year? So like in Vancouver, we'll say.
Not as much as in colder cities, because our cars sell for more when we take them north and back east, because there's not as much rust on them.
That is a very good point. Yeah, salt is super, super damaging to cars. Although I'd be curious if that's the case though, because people apply it and it rains and it gets washed away, and then we apply more.
Yeah.
So potentially. How much do you think gets applied in all of Canada, like each year? Just throw out a number.
40,000 tons.
40,000 tons?
A million tons.
So the short answer for all of this is we don't know because it's not regulated. We have no idea how much it gets applied. We don't know where it gets applied. However, they have made some estimations for Canada based on the sale of salt because they assume that if salt is purchased, it's used. And so it is estimated that 5 million tons of salt are applied to surfaces in Canada every single year. Obviously, this will vary a little bit with the weather, but that's kind of an average. So crazy amounts of salt. Where does it go? Mm-hmm.
Ditches.
Underground water.
Yeah, groundwater, streams, lakes, ditches, pretty much anywhere that stormwater is flowing, that salt is going to go with it. Do we think it affects anything in the environment?
Kills plants
Yep.
as well as
Yep, invertebrates. We can do next slide here, Connolly, please. So yes, it contaminates groundwater, surface water, soil. Salt is actually classified by Environment Canada as a toxic substance. The only reason we're allowed to use it is because of its public safety benefits. But it has adverse effects on pretty much everything that ingests it. Some things that even just walk on it or encounter it. It's poorly regulated, and what we're most interested in is salmon in general, but we kind of know how toxic salt is in general for some various species that we tested on, but when they do toxicity tests, you have essentially a series of tanks with different concentrations of whatever chemical you're looking at. And then you put the fish or bugs or whatever species you're wanting to test with, and you say, okay, at what point do they start dying? It's a little morbid, but that's how it works. But what we don't know, what we want to find out is what happens when you kind of go from fresh water and then you do a blast of salt water and then you go back to fresh water, because that's what's happening in the creeks. And so that's what these two are looking at. That's what the whole project's kind of looking at. Next slide, please. So which brings us to, what is the Road Salt and Salmon Project? So this big project, it's a 5-year research initiative. It started back in 2022. And it's trying to find out what effects is salt application having on the creeks, and in particular to the chum and coho salmon that are living in the creeks. We do care about other species as well, but those are the most common salmon species that are in urban creeks, so those are the ones that we're kind of focusing on at this point. The project is led by faculty and graduate students at UBC, SFU, and BCIT. It's supported by us at PSEC, and it's a collaboration with 13 different stewardship groups, including the Still Moon Art Society, throughout the Lower Mainland, so kind of from West Vancouver to Chilliwack. And so there's different components of the project. So there's field data collection by streamkeepers, and then there's laboratory experiments that are being done by the graduate students. And then there's a big kind of public education and engagement focus, which is why we're here. Next, please. So I really love how the Road Salt and Salmon Project got started because it's very much a bottom-up initiative. So this project actually got started because the Stony Creek Environment Committee, which is a streamkeeper group in Burnaby, they monitored conductivity, and we'll touch on why we choose conductivity after, but they monitored conductivity in Stony Creek for like over a decade. And they kept noticing these like spikes in salt, or in conductivity rather, and they were like, well, what is causing this? And so they actually traced it back to a salt shed up at SFU, and you can see the picture of it there. It is, and this is surprisingly not an uncommon way to store salt, which makes no sense to me because it's like this stuff melts when it gets wet and it's just exposed to the elements. But anyways, I digress. So they worked with SFU, and SFU actually ended up changing the way that they store their salt shed or their salt. So they now have a big shed that is fully enclosed. Salt can't get out. Amazing. But the salt spikes continued, and so that led them to question, okay, well, is this just residual salt that's in the soil that's kind of like leaching out into the creek? Is it because we put salt on the surfaces in the winter? Like, what is causing this? Is this something that other creeks are experiencing? And if so, what is this doing to the salmon? And so Alan James, who is this very determined, persistent volunteer with the Stony Creek group, came to talk to us and was like, okay, this is something I'm concerned about. He eventually brought all of the groups together, UBC, SFU, and BCIT, and brought the issue to them, and there was consensus that, yeah, this is something that we should probably look into. And so one thing led to another. The UBC folks applied for a grant on behalf of kind of everyone else in the partnership, and then they were awarded the grant, which is like $550,000 for the project. So, but this all got started because of a streamkeeper group that was monitoring the creek and noticed something that was seemingly concerning, and bringing that to the attention of people that could investigate. And so when I talk about conductivity spikes, this is kind of what Stony Creek was seeing. So for context, these red lines here, the lower red line is kind of where we want to stay below for like chronic things. So like we don't want to go above that line for more than like 30 days at a time. This is the line that we don't really want to go over for more than like a day or two at a time. And those blue lines are the conductivity spikes. So they're short term, but they're way higher than what we want. And so that was why it was a bit concerning for them. Next slide, please. Did I want to say anything else about this? No, I think we're good. Okay. So the primary research questions that we were kind of hoping to look at are, do other urban creeks experience these same spikes in salt? And if so, what effects are these having on juvenile salmon living in the creeks? Next slide, please. So how are we going to answer these questions? So the first question, the way that we're answering it is by monitoring conductivity in a whole bunch of creeks throughout the Lower Mainland to find out, okay, are we seeing these same trends in other creeks? Next slide, please. And so, sorry for those of you that hated science. It's only one slide. We'll get through it. But so it's a bit challenging to measure how much salt is actually in the water. You have to actually go out there and like take grab samples. But we choose to monitor conductivity because there's a direct relationship between conductivity and the amount of salt in the water. So salt is a combination of what's called a cation, which is basically just a little particle that has a positive charge, and then an anion, which is a little particle that has a negative charge. When they're stuck together, they don't have any charge because those charges cancel each other out, and so it's neutral. So solid salt has no charge. But when you put them in water, they dissolve and dissociate, and now you've got all these little charged particles floating around in the water, and so that actually makes the water conductive. And it's really easy to measure that, especially using like automated data loggers. Come on in. And so we're able to monitor the conductivity, and then we can do some fancy conversions. And when I say we, I mean them. We do these fancy conversions that will tell us how much salt is in the water based on how conductive the water is. So we use automated data loggers to do this so that we're not out there taking samples all the time, because we want consistent data trends that show us what's happening in the creeks. There's a variety of different road salts that are used, but in BC and throughout much of Canada, it's just sodium chloride. So it's the same type of salt that you would use for table salt, but not food safe. Please don't eat road salt, but same type of chemical. Next, please. So these are the locations of the little colorful dots that you see up there are the locations of the conductivity data loggers that we have. And they actually measure temperature, conductivity, and depth. And they do that every 10 minutes. So we get lots and lots and lots of data. And kind of in a variety of locations that range from kind of streams to retention ponds. Okay. So question number 2, what effects is this having on juvenile salmon living in the creeks? So we're kind of answering this in a couple of different ways. One is where the streamkeepers come in, and Connell will go over this more, but there's data collection that occurs, invertebrate sampling, and fish trapping every spring and fall in impacted and unimpacted parts of the creek to see if there is a difference in areas where we expect to get lots of salt impacts, so like downstream of a highway, of a parking lot, versus potentially, we say unimpacted, but let's be honest, it's the Lower Mainland. Everything's impacted, but areas that we assume are less impacted. And then The second way we're trying to answer this question is by the laboratory studies that Beast are going to talk about afterwards, where they essentially subject juvenile chum and coho salmon to the same salt pulses that we're seeing in the creeks, so that we can hopefully by the end of this say, okay, this is what we're seeing in the creeks, and this is what we expect it's doing to the fish in the creeks. And so what do we hope to achieve? Better understanding of what these effects are, specifically on chum and coho salmon. We hope to use this information to help improve regulations, or at least have regulations as far as road salt, so that at the very least, so that maybe you have to take like a little course or something like that, or read a little brochure about the fact that road salt is toxic before you're allowed to buy a bag of it, something of the sort. And then public awareness, because most people just don't really know that road salt is toxic, and so we want to try to kind of spread that awareness so that people can be a little bit more mindful when they're applying it. Thanks, Bees. That's it for my little intro. Do we have any questions at this point? Yeah.
I'm wondering if other places in the world regulate their road salt.
Ooh, that is a good question. I don't know. But that we should definitely look into, see what they have.
Interesting. Oh, also, sorry.
Oh, yeah.
Do you know of any alternatives? Like if
Ooh,
road salt was
we'll get there, we'll get there.
Okay,
We're going to finish with that.
I think in Japan, when I lived in Sapporo, all the cars had studded tires because they didn't use salt.
Interesting.
Yeah, but that's my brain from 35 years ago, so you might need to be
So maybe things have
corroborated.
changed. I remember reading an article of these people that were trying to create a type of concrete that had salt in it when just like release it when temperatures got low. Which on the one hand, I'm like, okay, then it would only get applied when you needed it, but then it's consistent salt when.
They also had
Yeah.
heated sidewalks.
Oh,
More fancy.
bougie.
Yeah, well, it was Sapporo after the 88 Olympics, right?
Right.
80, whatever Olympics it was they had there. Yeah.
Question back there.
Do you know what agency would be responsible in regulating salts?
Ooh, that's a good question. It'd probably be Environment Canada, I would assume. DFO might be involved, given that it is affecting fish habitat, but there's this weird division where, so like DFO regulates the Fisheries Act, with the exception of Section 36, which has to do with like chemicals and toxins and stuff like that in the water. So I'd probably say mostly Environment Canada, but you'd think there'd probably be some municipal stuff in there as well, given that they're the ones that are applying. But, yeah.
The salmon start in freshwater and they have to go into saltwater and come back. Is it how severe the spikes are that affect them, or because they're just dry that they're hitting this? Or?
I think it has to do with timing. So, yes, they do. Enough of that talking. Yeah, so that is a really good point. So a lot of people do say that, where it's like, but salmon go to saltwater anyway, so why can't they just deal with it? Salmon have, at various life stages, they've evolved to be in fresh or salt water, and so they don't go to the saltwater area until their bodies are ready. So they've got these huge physiological changes that take place where they go from having to like try and keep salt in their body, because you need a little bit of salt in your body, but the fresh water around you has no salt. The salt is trying to leave your body and you're trying to keep it in. And then all of a sudden they go to a salty area and now they're trying to pump that salt out of their body because they don't want it all in them. So the salt hits them at a life stage when they're not ready to do that, like to deal with the salt. And when they go down to the ocean too, they also go down so that they can kind of like gradually get there, so they can hang out in like brackish waters and stuff like that. Yeah, exactly. So timing and just like the speed of it as well.
And do they spend time in the salt marshes that are sort of half?
Yeah, like the estuary areas. Yeah.
Yeah, sort of, sorry.
Yeah.
How do the concentrations compare to like salt water in the ocean? Like, are they similar?
That is a very good question.
concentrations Or higher?
Seawater is about 50,000. The unit we use for conductivity is microsiemens. And so in some creeks we've hit like 8, 10, 11,000, so about a fifth of seawater. In a couple of the retention ponds where we haven't seen any salmon in the ponds, but there are some downstream, we've hit like 30,000 microsiemens, so like 60% of seawater. So it's, oh, wait, is that math right there? Yeah, we're good, okay. So yeah, pretty darn salty, considering a creek is supposed to be less than like, on average, like 500 microsiemens in our area here where the water's really soft. So very salty, yeah.
Are there any mitigation strategies like grading infrastructure that are effective in treating stormwater?
Yes. So I don't specifically have a slide for that, but remind me about green infrastructure. We would talk about kind of like alternatives and stuff at the end, because that is a really good way to deal with it. All right. Yeah.
It sort of goes with the mitigation strategies, and I'm just talking off the top of my head on reacting to you. And what you've said is it's Canada and it's cold, and that's the reality for weather.
Yeah.
So there are only a few other countries really that have accurate comparisons. Like I don't know which Sapporo is. So, but the reality is for cost, I don't see Vancouver going, yeah, we're going to do heated sidewalks.
Yeah.
So the reality is, like in Ontario, is a combination of gravel for roads and salt, because the reality is for safety for cars
Yeah.
and the 401. So there's lots of like realistic things to deal with. So I just want to throw that out there.
No, absolutely. And spoiler for the last little bit, at this point, we're pretty much saying use less. And we're going to talk a little bit about how much is effective versus.
I would actually like to react to that because I'm from a little town from Europe, from the Czech Republic, and we have mineral springs, and there's actually a ban on the salt during the winter. We can use only gravel during the winter. Only on the main road, on some section you can use salt, but the other part of
That's why I'm
town
wondering
is
about
only gravel
mitigation
and sand,
strategies.
basically.
Interesting.
Mm.
Okay.
And I know sand is used too.
Yeah, I just had a bit of traction there.
Southern Ontario, so it doesn't.
Yeah, and I haven't looked too much into like how well sand stays in place, because I know that some people have said, well, if the sand all washes into the creeks as well, then you've got issues of smothering the eggs and the reds that are in there. So, and then one suggestion was if you apply beet juice, it helps the salt stick. But then we had a toxicologist be like, yeah, but the chemicals that are in beet juice are even worse than the salt. So it's one of those things where you're like, ah. But yeah, we'll touch a little bit on that to kind of finish things up. But for now, I think I will pass it over to Connolly so we don't go over time. But great questions. Thanks, you guys. Do you want me to press the arrow for you, or do you got it?
Ooh. Okay. I'm just going to talk a little bit about how the Still Creek Steamkeepers support the project. Some of you may recognize yourselves, or others you know in the slideshow here. So we help collect data in a couple locations along Still Creek. We help with juvenile fish trapping, invertebrate sampling, and the data logger downloads for the conductivity information. So quickly, just where we gather data. One site is in Renfrew Ravine Park at the boardwalk on the north end. We call this the non-impacted site. Here, the riparian or the habitat and tree area around the creek is much wider than our other site. So the road isn't right next to the creek. There's a bit of a barrier there. It takes, hopefully, salt a bit longer to actually enter the creek at this site. Yes, yeah. And our impacted site is down at Cornet Road and Natal Street, just by the Canadian Tire. It's pretty clear in this image that the riparian or that habitat strip is much smaller around the creek. It's kind of right next to the road and some industrial businesses, so there's quite a big difference in the surrounding habitat of the creek. So I'll start with juvenile fish trapping. This has been kind of a less exciting venture for the Still Creek Steamkeepers. We've sampled in October this year and last, and we put 5 traps at each of those sites. And so far we have caught no juvenile fish. But that doesn't mean that there's not juvenile fish, just for some reason we aren't catching them.
I also argue that doesn't mean no success, it means no fish.
Yes, sorry. Sorry.
So important data.
Yes. Yeah, so we do that. One thing that's more exciting, I'll say, is our invertebrate sampling. We sample in spring and fall each year. We use the Cerber sampler, which is this white, it's a really fine mesh net, and we face it upstream. The stream flows through it, and then we rub the rocks in front of it, and all the inverts kind of get washed down into the net. And then we empty out the net, and we count each invert like each individual invertebrate, which invertebrates are like bugs or worms or small little critters living in the creek. And this takes a lot of volunteer effort. We had a really big year for sampling this year. We counted almost 1,400 inverts at our non-impacted site and over 1,600 at the impacted site in the spring. And then we had almost 900 in the non-impacted and almost 600 in the impacted this fall. So none of our students here today use the invert data to my knowledge, but a couple other master students at SFU use it. And basically, a couple of these species are really good indicators of stream health. So this guy here is a mayfly, and they'll only live in streams with pretty good quality, like dissolved oxygen content and temperature. So seeing these guys is a sign that like something is going right in Still Creek. As you can see, we saw lots of them. It was definitely one of the primary species we saw in the creek this year. And then we have a little flatworm planaria that's kind of blurry in the background there. He's more like tolerant to pollution. So if we see more of those, maybe the creek isn't as healthy as we thought. But I'm not analyzing this data statistically, so I cannot say whether the non-impacted or impacted site is healthier, but I'm sure someone at SFU could. And then the last thing we help with is the data download. So we have 5 data loggers in Still Creek. We have 2 conductivity, which helps measure salt. Claire and Carly will show some cool graphs later of the Still Creek loggers over time. And then 3 that measure temperature, which is super important for fish and stream health. And basically what that looks like for us is we put our waders on and go out to the stream, collect the logger, and connect it to our phone and send the data to who needs it. Yeah. We did have some challenges this year, which were kind of fun. We had lots and lots of bugs, which was lots and lots of time. We ended up running well into the evening this night, and we all had our headlamps and flashlights out counting. And it's tedious, man. You've got the little pipette, and you're picking up each individual insect. It's a lot of time, but we had fun. And then we did have a logger go missing and stolen, and thank you, Nikki and PSF for replacing it, and it's back in the water collecting more data. So yeah, some adventures out there. And if you want to join us, you can send me an email at connolly@stillmoonarts.ca or streamkeepers@stillmoonarts.ca to sign up for our mailing list. Any questions? Yeah.
Did you ever find any difference, or was it just that one creek, where there'd be water inflow from treated water into the creek?
I don't have that information. Yeah, I'm not.
Is there any difference in the water quality based on whether it's inflow?
Well, or if there's
water?
more examples of like, well, I guess we know the fish, but invertebrates or more in, higher number.
I don't think we specifically looked at where the inputs are, and we were just more so on like how much riparian cover there is.
Yeah.
But yeah, that could be another way to look at it, for sure.
We do have maps that show where all the storm sewers come in, if you want them.
If any of the students tackle that, I will absolutely touch base.
Awesome.
But I was gonna say, yeah, that'd be useful for you guys. Feel free to request it.
Sweet. Yeah, Daniel.
I noticed there was a kind of a 50% difference in invertebrate counts in the springtime and fall. If there's any idea why there's less actually in the fall.
I believe they emerge closer to the spring, and so they'll have just higher numbers overall in the spring because they're all kind of coming out at once, and then they'll kind of die off over that period till the fall, is my understanding. I don't know if Nikki or...
I'm not a bug expert, but not all the water critters live in the water all the time. Like they'll start out as larvae in the water, and then they emerge and next thing you know they're a flying little critter. So I'm not an expert whatsoever, but I would assume the comment is right, and that they're probably just not in the water at that time.
Yeah.
Are you counting types of invertebrates too, or just how many?
Yeah, we do how many, and then we identify as best we can to species or like taxa if it's too hard to get to species. Yeah, Catherine.
Do you work with school groups doing invertebrate sampling also? Because I know you do like the planting with school groups too.
Not at this point, but we have a very exciting part of the project overall is like a field trip kit for teachers, where they can take the kit in, the kids learn a bit about the road salt project, and then they get to come to the stream and do the invertebrate count. So we're excited to pilot that, and we'll see how it goes. Oh, okay, great. Yes, more to come.
There's like a charity there called EcoSpark, and that's like their main project. Their project's called like Changing Creeks, and they do like water quality monitoring with benthics with like school groups all around, like the PTA.
Very cool.
So, yeah, very good.
Mm-hmm.
Yeah, even like kids that like aren't used to being outside, like they get pretty excited looking at the bugs.
When we did pilot the kids, there was some feedback from one of the kids that was like, yeah, this experience made me do something that I probably wouldn't do by choice, but it was interesting. So grade 4.
Awesome. Sweet. Okay, I'll pass it off to. Okay, sweet, to Carly.
Thank you. That's a thing. So yeah, again, my name is Carly Winter. I'm one of the master students with UBC working on the road salt project. And so I work closely with Claire Kilger, so she'll talk about her research more later. Colin Bronner, Trish Schulte, and Chris Wood, there are 3 supervisors on the project. Okay, well, we'll pretend there is writing in there. I don't know why there isn't. So the first and top bubble are the streamkeeper groups that are part of the project, and without them, we would not have this project going. I would not have a master's, and it's really thank you to many of you and many of the groups that provide data which really guide our laboratory studies. And so, UBC would be here, and we do all the studies looking at how road salt contamination is impacting Coho salmon. Simon Fraser and BCIT are also involved, so they're looking at how road salt contamination is impacting those benthic invertebrates in streams. So a lot of the surveys that are done, they can look at that data, see how many pollution tolerant and intolerant species is that because of road salt contamination. And then of course DFO is also involved, playing a huge role in communication and allowing us to not only communicate our findings to members of the public, but also all our volunteers as well. And so this is a very scary graph, so I will walk you through this. But this is where all those water quality loggers, this is what they record, so both temperature and conductivity. And Claire will talk much more in depth about this after. So these colorful spikes are specific conductance, which correlates with that y-axis there, and the different colors represents the different monitoring locations, and these are just the loggers in streams and rivers, so not retention ponds. And then we also have temperature, which is this black line, and that corresponds to water temperature on this axis here. And the main takeaway is that when you see a dip in temperature, it coincides with this spike in conductivity. And so, you can go to the next slide. And so another way to look at this is, again, we have those same spikes in conductivity. You can use those conductivity estimates to get an estimate of chloride contamination. And what we see, and what Nikki kind of pointed out earlier, is that in BC we have a long-term guideline for chloride and a short-term guideline. And the main one I want you to focus on is the short-term acute guideline. So that means that at any given point, chloride is not supposed to surpass 600 milligrams per liter of chloride. So that's this dashed line. And as you can see, we go above and beyond that quite frequently. Next slide. So more than tenfold. And so with that data, we're looking at, okay, so we see these huge spikes in conductivity. How does that overlap with when coho salmon come to spawn and those early life stages? And so my research in particular focuses on coho salmon. And so they come to spawn around September to December. Their eggs are rearing in streams up until when they hatch around December to March. And that's when we see these frequent pulses in road salt occurring. And so during these early stages, when they're supposed to be in fresh water, they're unable to really flee from these salt pulses. So how does salt contamination impact their survival or development? And so how we started tackling this, next slide. We first did a preliminary trial with rainbow trout. So I started of May 2023, which seems so long ago. And we don't have coho at that time, so we used rainbow trout as a quick preliminary trial. And so what we did is, you can go next slide. We conducted a 24-hour salt pulse at 6 different salt concentrations based off what we were seeing from those water quality loggers. And so the concentrations, well, other than the control, so no salt, we started at 600 milligrams per liter of chloride, and that increased until we surpassed what the highest pulse ever recorded was, which was around 9 or above 4,800. So yeah, the highest pulse was 9,600 milligrams per liter of chloride. And so again, that was just 24 hours. And I exposed individuals either just after fertilization, at the eyed stage, so when eggs are developing, they get very prominent dark spots, which are their eyes, and then just a week after hatch. And again, these are kind of periods when we would see these frequent and high concentrations of road salt contamination. And so for the sake of time, I'll show results from this first exposure. We didn't see any drastic mortality from any of these salt concentrations at hatch or at the eyed stage. So what we have here is end survival it was at swim up, so a few weeks after hatch, and the chloride concentration they previously got exposed to as eggs. And as you can see, the 3 lowest concentrations from just a 24-hour exposure, they were fine. However, there was a very steep threshold where once they reached the 2,400 and above, there was pretty drastic mortality. We did have, you might be asking, why is this one have no survivors and this one has slightly more? We also didn't know what happened there. So we decided to repeat this experiment really quickly before we worked with coho. Next slide. And we did the same thing, just different individuals, same salt concentrations. And again, we saw a very similar trend where there was high survival up until there was no survival. So with that, we really used those rainbow trout studies to guide and shape how we were going to work with coho. And so what we did, we adjusted our salt concentrations a bit, still based off what we were seeing in the streams and maybe the more frequent concentrations we're seeing in streams. So again, control, so no salt. We started at that 600 milligrams per liter, so that's BC's guideline of we should not surpass. And then I went up to 4,800 milligrams per liter of chloride and just added a middle concentration here. So when you do some of these tox tests, you want to kind of find a concentration when there is about 50% mortality, 50% survival. And when we did the rainbow trout stuff, if you remember, I had high survival up until they all died. So that's why we added this middle concentration here to see if we could get kind of what they call LC50, a lethal concentration in which 50% mortality occurs. And that's what a lot of environmental regulations base their guidelines off of. And so with that, we then kind of evaluated the stages for coho's development that we would expose individuals to one of these salt pulse concentrations. Good, next slide. Oh, go back. I forgot that. Hopefully Claire will correct me, because I just looked at this very quickly. I looked at the previous data, and I believe Still Creek's, the highest pulse ever recorded, was estimated around 2,500 milligrams per liter of chloride. So you can keep that in mind as I go. It'd be around those 2 highest salt concentrations. And so then individuals were exposed to one of those 6 concentrations, so just a single salt pulse, either at fertilization, just after fertilization, or at 50% hatch. And I'll kind of talk about each one of those stages as I go. Oh yeah, so these are some photos. I was very lucky to work with Capilano Hatchery, and they provided the eggs and milk that were used for this experiment. So come this time, these coho have come a long ways to spawn, and then a certain subset of those individuals are used by the hatchery to then release more individuals to kind of help sustain the population of coho. So I took a small subset from them, and they were used for this experiment. And so what I got were eggs from 6 females, milk or sperm from 5 males, and that was pooled together and used to fertilize my eggs. And for these coho experiments, I kept the eggs from different females separated to see any differences across families. So I refer to them as families A through F throughout my presentation. And so just to touch on lethal effects, so did any of these salt concentrations cause any mortality at any of those life stages? So I'll start with this first exposure here. So individuals were in fresh water, then they hatched. I exposed them to a salt pulse. After 24 hours, they were back in fresh water up until swim up, so their yolk sac was fully absorbed. And so that's what they look like at hatch. They're quite cute. They have giant yolk sacs. At this stage, they're not swimming very well. They don't have fully functioning gills to ion regulate. And yeah, they basically rely on that yolk sac for nutrients as they grow. And so here, I'm just showing daily survival and over time. So you can think of ATUs if you're not familiar with it. Basically for fish develop faster at warmer temperatures. So we accumulate daily temperature because the fish that maybe they're fertilized on the same day, but if one's in 10-degree water and one's in 14-degree water, the 14-degree water will develop faster. So we use accumulated thermal units as a better proxy for their age. But just think about this as survival over time. And then the different colored lines represent the different salt exposure individuals got exposed to. The light blue is the control, and the dark red is the highest salt concentration. And as you can see, there is no significant impact following their salt exposure on survival, which is good. I will say I don't have any images of this, and I always wish I do. In my highest salt concentration, when I came in, I had thought all the individuals were dead. I was like panicked, but it almost looked like they were immobilized. And then when I was slowly decreasing the salinity, they started to get more spunky and more active. So potentially I was reaching a threshold. Any higher or any longer at that concentration, there could have been mortality. Whether that would lead to mortality in nature, probably. But anyways, so yeah, the next one. Next, for this exposure, so eggs, after they are fertilized, they undergo water hardening. And this basically allows them to survive in, streams. And so during this period, they're very, again, at the mercy of their environment. So we wanted to see a 24-hour salt exposure when eggs are just sitting, developing in reeds or reds. How does that impact their survival and development? So again, 24 hours, then back in fresh water, up all the way till swim up. And so this is just showing my survival at the very end of the test. Across each family, blue-colored bars are the lowest salt concentration. And as you can see, no real difference in survival across those 3 lowest concentrations, maybe across families. However, next slide, with the highest 3 salt pulses, again, just 24 hours, there's drastic impact on survival. And this actually varied across my families, which was super interesting, which I'll talk a bit on the next slide. So here, again, looking at daily survival over time. My 2 families, so families A and C, they are similar, where the higher the salt pulse they experience, there's an increase in mortality. Next slide. Families B and D, they differ from other families, but not each other, where they had a very steep threshold, where once they hit that 1,800 milligrams per liter of chloride, there is drastic mortality. Family F had its own threshold compared to the others. Once it hit around 2,400 milligrams per liter, there's drastic mortality. Family E was doing something very different from the rest. It virtually had no mortality up until that highest salt concentration, which was, again, very interesting. Weren't expecting that, to be honest. and again, if you put into perspective, Still Creek's highest pulse, it was again around that orange concentration. So you can imagine if eggs were developing in those streams and experienced that high of concentration, there could be severe mortality. And then lastly, we looked at fertilization success. So these kind of exposure 1 and exposure 2 slightly differ because this was just following, the one I just spoke on was just following fertilization, so during early stages of development, versus exposure 1. Here we looked at does any of the salt, so if spawners are coming to spawn, does any of the salt impact sperm's ability to fertilize eggs? And so what we saw here is that, no, interestingly, we saw that there is no impact on fertilization success or survival across any of our salt concentrations, which kind of confirms to us that it is really that early stages following fertilization when eggs are just sitting, developing in streams, that they're quite vulnerable to those salt pulses. And so just to summarize all the lethal effects, so there's significant mortality at concentrations above or equal to 1,200 milligrams per liter of chloride, again, during the early stages when eggs are developing in streams. Salt did not appear to impact fertilization success or survival at hatch, at the concentrations I tested at least. And coho families really differed in their salt tolerance. And again, that was not sure why that is. We kind of were interested to do more research to explore that. Now, briefly to touch on some sublethal effects. So if the salt didn't cause any mortality, were there any impacts to individuals' fitness potentially? So this is just one note. So eggs, during this period after fertilization, they're supposed to swell quite a bit. And we actually saw that during these salt pulses, they actually start to shrink. Whether that is a reason for some of their mortality, not sure, could be. You can go to the next one. Also, during that early stage, so again, just eggs getting exposed to a salt pulse, I found that when eggs or individuals got exposed to a pulse at that highest salt concentration, there is a delay for them to hatch, which again, that could potentially impact their survival in streams. And yeah, you can see that with that shift there. All the other individuals hatched around 1 point, and then the individuals who got exposed, again, really early on in development, were slightly delayed to hatch. So individuals, the few survivors that there were in these higher concentrations, they had a higher percentage of being deformed. So these individuals were actually alive come when I terminated the test. Obviously, there were severe deformities, spinal deformities, individuals missing eyes. So obviously, they were alive at the end of the test, but they wouldn't obviously continue living in streams. And so again, we saw that in 3 highest salt exposures. And then the one last thing I want to touch on is ion content. It's really important, like all beings, we have to uptake salt when we're low, and we have to excrete salt when we have too much. And so fish are exactly the same, and they do this primarily through their gills. However, at these early stages, they actually don't have fully functioning gills. So we looked at ion content to see if it at all changed because of these salt pulses. And so we saw that eggs, their sodium increased with the higher salt pulses, but we didn't see that at individuals who got exposed at hatch. Next one. We also saw similar trends in potassium. So potassium was increasing in eggs when they were exposed to the higher salt concentrations, but again, we didn't see that in individuals at hatch. And that could be because they are a bit more capable of ion regulation at this stage, and we didn't see any mortality, so that could be an indicator of, again, why we saw mortality during that early stage, but not later on. And okay, I promise this one's the last one. So calcium. So calcium's really important for eggs when they are just after fertilizing and they start to harden. And what we found for individuals at hatch, so either individuals who were finishing their salt exposure or individuals who, again, months before got exposed to salt and then 4 months later they hatched, I sampled both of them, and they both had a trend with increasing calcium with their higher salt exposure. So this could mean that, again, that early salt exposure as eggs could have lasting effects that they're still trying to kind of counteract from come 4 months after that salt exposure. So again, kind of indicating that this 24-hour salt pulse could have lasting sublethal effects, which we're still kind of researching currently. And so just to summarize all that, so embryos, again, are developing eggs. When they got exposed to the highest salt pulse, they experienced a delay in hatching. And then my 3 highest concentrations, they had a higher percentage of deformities that were, again, very severe, where it would lead to mortality in nature. And then lastly, salt exposures did appear to impact embryo and larvae's ion content, suggesting some disruption to their ion regulatory ability. And so I just want to end with some of these images. So I took these images on UBC campus, and I was going in the morning, seeing them salting in the morning, afternoon, and then at night. And there was, I promise you, no precipitation days before or after this. It was just completely, the streets were completely white just from salt. And so this is what I think we're trying to advocate, is not to ban salt by any means, because if you saw the 600 milligrams per liter of chloride, which is BC's guideline, that did not cause any mortality or lethal effects from any of our co-hosts. So we're trying to stay within that range. And so it's like, how do we go about doing that? Probably using salt smarter. So we hope that our research really guides smarter salting practices. And so, yeah. And then lastly, I just will touch on, we have a road salt project website. So again, everyone uses salt. So it's really just bringing awareness to everyone to use it more mindfully. And so to help with that, there's a website where all our institutes, streamkeepers, we can share information about the project so people can follow along as we go. And so, yeah, that is everything, I think. Is there any other slides? Maybe go to the next one? Yes, this is everything. Okay, yeah. Thank you very much. I can take any questions if there are. Yeah.
I'm just wondering about the 1 hour after 1 day or 1 hour
Yeah.
after fertilization. Is that for the stand-in for the whole time that they're eggs before they hatch?
Good question. So coho, they're in as eggs for quite some time. Like it was 2 or 3 months. So we only did that early stage. I know Claire did maybe a week or so you had those pulses going. Yeah. So we looked at salt exposure within that week. Months later at the eyed stage, we haven't looked at. So if you remember from my trout stuff, I looked when they were at the eyed stage. So they're a lot sturdier, even mechanically, and there I didn't see any mortality. So it seems to be maybe that early few months, I want to say, when there's still early stages of cell division, and kind of that seems to be the most sensitive.
Like the salmon here are spawning in late October, early November. So when are we in that vulnerable stage? Like, is that November through January, the times when we're most likely to have road salt?
Yeah, I would say, that's exactly accurate. We do have some runs that go into December. And it really depends year to year. Those runs can totally change. But I would say November is probably the most sensitive based off how often we see the salt and the kind of number of spawners that are coming. Whoa, that was the exact same time.
My question is, why the 24-hour pulses? Is it, I guess, like a two-part question? When salt is first spread in the morning, is it seen through the waters that the salt is staying in the stream system for that amount of time?
Yeah, so I think the average was around 1 to 2 days, and Claire will talk a lot more about she really analyzed all the pulses. 1 to 2 days was kind of the average, so we did a conservative 24 hours. And depending on the streams, concentrations can really stay for quite a while, where others can go up and down quite frequently. So it's really stream to stream basis. Yeah. Yeah, good.
I know that your research is on coho. Do you know if any of the other researchers took a look at chum to measure the same thing? If the results were similar or different?
Yeah, we just brought on another master student, and he's doing similar work but with chum. Yeah. Yeah. And then you had a question.
So with the pulses, is the concentration
Yeah, so I brought it up over the course of around an hour, and then they were held there, and then I brought it down over the course of an hour. And from the few loggers that we have that are real time and we can see the measurements, there have been some that you see salt on the streets and it goes up so fast, like shockingly. So, yeah, that's your question. Yeah.
You mentioned the different families of coho had different results. I'm just curious, is it only hatchery salmon you're looking at, or is it also wild?
Good question. Yes. So Trish Schulte, she has a huge molecular background, and so from her work that she's done on hatchery versus wild, genetically they don't actually differ too much at all. So the individuals we got are probably mostly individuals who were hatched in streams but then released, so they go to sea and then come back. But that is a very good question. I actually just got more coho eggs to explore that. So I got eggs from 3 wild individuals and eggs from 3 hatchery individuals, but there shouldn't be a big difference because they all go to sea and they all come back to the same ground. Yeah.
It's also interesting because so the hatcheries, they collect the fish that come back, but sometimes it's a mix of ones that were from a hatchery to begin with and wild to begin with. So they may have been raised in a hatchery, but their parents may have been wild.
Yeah, like each year they only restock individuals or spawn individuals that are wild. They don't respawn ones that were hatchery released. So that's why genetically they're very similar, if that makes sense. Which I just learned too, so that's a really good question. Yeah. Yeah.
I kind of have a question, but it's a little bit of a long shot. I know that, like, with fish farms and things, can sometimes complicate salmon's, like, ability to respond to changing conditions and everything, and just, like, their physiological traits. So I'm curious, I don't think you would know this, but maybe someone is doing, like, research on, you know, like, the removal of fish farms, and maybe if that's having any impact on the changes that they're having in regards to, like, salt tolerance and everything.
To be honest, I have no idea, but it would be cool because I know that is a huge issue of how do you have an answer? I feel like you were like itching for.
I don't know a specific answer because the fish farms are still in the water. So
Yeah.
Right. And maybe in the future.
Yeah,
But, I mean,
it would be
I
cool.
know just from having worked at the Pacific Salmon Foundation in the past, like, I don't think if we're just starting salmon research, no one would have, or sorry, the salt research, no one would have looked at that specifically, but in the big report that was done on the health of wild salmon, 10 years ago now, 15 years ago, when they were looking at the fish farms and other factors, one thing that came through clearly there is that there is a lot of individual factors stressing the fish. And when you add all those factors together, they come out much worse. So if you have a fish who may be slight deformities or reduced osmoregulation from salt exposure at birth, and then maybe if it's going through a polluted estuary or an estuary with a lot of traffic where there's not as much food, or if the temperature isn't right there, that's going to further weaken it. And then if it hits the fish farm and maybe picks up some sea lice or things like that, it's less able to respond. So this is, the phrase we use is like cumulative effects.
Mhm.
Like you can also have complex interactions, but definitely I would expect that the salt would be kind of one more stressor that's being added together with the fish farms and the climate change, sea temperatures, estuary temperatures, things like that. So I'm sure, they're
Yeah.
they add together.
Yeah.
And I'm 100% sure there will be researchers that are very interested in learning and like seeing what changes there are in the salmon populations as the fish farms get removed.
Okay, I will wiggle away if there's no more questions. Oh yeah.
One quick
Yeah,
question.
no worries.
Curious, for the experience you're running, how many individuals would have been in each? Like when you say lethality was 10%, like what was the whole population?
Yeah, so I started with around 100 individuals per replicate, and I had 6 replicates, so I had around 600 per exposure group. Definitely, so that's why the stats aren't significant, because with the deformities, there is such high mortality that I don't have a lot of individuals remaining in those. I don't know the exact number. Yeah, the main takeaway from that is if you're lucky to survive, you're probably deformed. Let's see.
Okay, so my name's Claire. I'm one of the other master's students on the Road Salt project at UBC. My focus was more of the water quality analysis of that logger data that's been mentioned a number of times today, and then also looking at how kind of repeated pulses early in life are affecting coho. So I'm going to talk about 3 key questions today. 1, how is road salt affecting conductivity across Vancouver? Little sneak peek at specifically Still Creek. Are those conductivity increases related to road salt? Can we kind of fact check that? And then how are repeated pulses affecting early development of coho? So going into question 1, how is road salt affecting conductivity? And we've gone over this a couple of times, so I won't belabor the point, but there's almost 40 loggers across Lower Mainland collecting data with hundreds of volunteer hours going into that. So thank you. We now have almost 4 winters of data, which is incredible, and that's conductivity, temperature, and water level. And so for this plot, I've just plotted kind of every creek, so almost those 40 creeks over the last 4 years. And what we're seeing is that every year we're getting these like massive spikes only in the wintertime. The highest pulse we've recorded was over 20,000 microsiemens per centimeter. So it's almost 10 times that acute guideline for chloride, or over 10 times. But what about Still Creek? So we are here at the Vancouver Public Library. If you haven't been to Still Creek, it sounds like many of you in the room have. It's just north of us, runs into Burnaby Lake, and then eventually out to the Fraser. Right. And so there are 2 loggers in Still Creek. I don't know, tell me if you can see a creek in those images. But basically, it's somewhere in this small treed area in that riparian buffer zone. And so there's 1 logger in each of these locations. The Grandview Highway one is just downstream of the Grandview Highway, so it's really next to the road. The Vancouver Film Studios one is still next to a bunch of parking lots, but it's at least upstream of Highway 1 and Boundary Road, so it's not receiving those inputs necessarily. And so if we want to compare these locations, again, immediately downstream of Grandview Highway, both are surrounded by commercial properties, industrial properties, have a riparian buffer zone, not huge, and they're quite treed and in a deep valley. So not a lot of land for kind of stormwater to run across and maybe collect some of that salt. And just keep in mind, Still 05 is kind of the upstream site. Still 04 is kind of the downstream. It sounds like they might line up with your impacted and unimpacted sampling locations. And so this is what the data for both of those sites look like. This Grandview, I think I have them confused actually, it's opposite, sorry. This Grandview Highway one in blue is getting spikes that are dramatically higher than the
Film studios?
Yeah. So this labeling is swapped, sorry. Is getting dramatically higher conductivity readings, which is kind of interesting since it is the one that's kind of immediately downstream from a road. That salt is getting into the creek. Mm-hmm.
I think it was last winter, it might have been an atmospheric river event, but like along Cornet and the town,
Yeah.
there's so much water flowing down, it's over the curb. Like the
Right.
curbs have disappeared. So it's washing down from that entire.
You
Yeah.
get everything on Grandview Highway.
Yeah. Oh, 100%. Just right into the creek.
So sorry, just to make sure I have this right, the legend is incorrect.
Yes.
And the blue ones are Vancouver Film Studio, which it's
The blue one-
basically Cornet Road, for those of us who do streamkeeping around here.
The blue one is the Grandview Highway.
Yes.
Yes,
That's
yes.
what I was wrong. And the red
Sorry.
one's like on Grandview Highway by the Staples there, if people know where the Staples.
So the red one is Grandview Highway by the Staples.
No, they're opposite.
Oh,
Grandview
Yeah.
Highway is the bad.
Yeah, we'll just ignore this. Grandview Highway is blue and it is doing worse, is the main takeaway. What I found interesting is they're only about 1 kilometer apart, and so that salt isn't traveling down that distance necessarily, which is kind of interesting to know. Yeah. So if there's any other analyses for Still Creek you'd like done, I'm happy to do those if requested. But yeah, next slide. So to kind of take that massive amount of data from the loggers and go back into the lab, had to kind of figure out what is the average pulse looking like. And so here we just have the maximum peak value, so the highest concentration that was read on a pulse, and the number of times we're seeing that value. And so the mean value for these chloride pulses is kind of often in between the two guidelines. So it's kind of a nice comfy spot to be, but 10% of the time the peaks are exceeding 2,400 milligrams per liter of chloride, which is almost 4 times that acute guideline. And how long are they lasting? Same deal, we have a histogram of peak duration in days and the number of times we're seeing those values. Obviously skewed very, very, very short, but we do have some extreme values, kind of up to these 15-day, 2-week long pulses in some places. The average is kind of around 1 to 2 days. So 70% of the time, the peaks are lasting a day or less, which is where we got that 24-hour value from. Okay, next slide. And so here we're looking at what air temperature are these peaks occurring at. We know they don't salt the roads unless it kind of hits a threshold, that threshold being 10 degrees. That's when we see all the peaks. So that correlates very well. The average is about 3 degrees when they're salting the most. Okay. And then here we have kind of the number of peaks per day scattered across the months, and this is the average of all of the data for all of the creeks. Basically, the takeaway here, we're only seeing peaks November to March. We just learned kind of in another meeting that correlates with when the contracts for private salting, that's their boundaries. So it lines up a little bit. And at the worst, peaks are occurring about 3 times a week. And so are these increases in conductivity, really related to road salt was one of the other questions we had. So Carly and I went out water quality sampling last winter, right after kind of the biggest snowfall of the year, if you remember it. So we got out as soon as you could get a car on the road safely and took some water samples, including in Still Creek, just to kind of measure that chloride and really ground truth our assumption that it's road salt. And so we got 5 samples from 4 streams, and we matched that with the logger specific conductance, of course calculated a chloride value, and then compared those 2 values to see kind of how close they are. And we were within about 10 to 20%, which is good for this kind of measurement. That to me says we can use our calculated chloride value based on the loggers and have a reasonably good estimate of what is going on in the creeks. Okay. And so again, this is just lining up timelines. We're having these peaks November to March. Coho are coming back kind of into the fall, are spawning November, December. They hatch January, February, and then are kind of more free swimming in March. And so these peaks are lining up exactly with their most sensitive life stages. So how would these repeated pulses, because we're seeing they're happening kind of back to back to back, maybe even 3 times a week, how would that repetition of stress affect them early in life? And so before I dive into it, I'll just briefly explain when salmonid eggs are fertilized, they undergo something called water hardening. So sperm meets egg, and then egg kind of swells, takes on water, and that outer layer, the chorion, hardens to protect it and give the embryo room to kind of grow and move. And so that first initial kind of activation of the egg in normal or in nature just happens with fertilization, but in the lab we can separate it. So you fertilize them dry and then add them to water, and that starts this water hardening process. Okay. And so for my experiments, I wanted to see if that water hardening process, if we allowed that to happen in freshwater, say, would that kind of save some of these embryos? And so I had two sets of eggs exposed right after fertilization. One of them was activated in that freshwater, one of them activated directly in the saltwater pulse, and then also a group that were exposed at hatch. And so each of these life stages were exposed to either 1, 2, or 3 pulses, or none. And it was all a 24-hour pulse at that 2,400 milligrams per liter chloride, which is the 4 times that we're seeing about 10% of the time in streams. All right. So again, had eggs from 5 females and pulled milk from 6 males to fertilize all of these families for all treatment groups. So some quick results. The eggs from female 1, 2, and 6 all behaved quite similarly and weren't particularly perturbed by that salt pulse. And so their survival was quite good across 1, 2, or 3 pulses. Female 4, we start to see kind of decline in survival, particularly, at all pulse numbers, and just the control had normal survival. And then female 5 was a little bit more of a graded response, reacting a little bit more kind of with each number of pulses. Okay. And if we compare those eggs that were allowed to activate in fresh water and those that went right into the salt pulse, interestingly, there is absolutely zero difference in survival. So it's not that particular event that's being affected by the salt, even if it's the next 24 hours it is. And if we look at survival based on the number of pulses that an egg experienced, we do see an increase in mortality with increasing number of pulses. And so because these pulses were kind of carried out across the first week of development, it's clear they're sensitive throughout that period, just based on this. Okay, as Carly mentioned, we saw differences in kind of egg swelling with them not being able to take on as much water in the salt concentration. So I won't belabor this much either, but just so that you can see the control in blue consistently had larger egg diameter than the other conditions, and no real differences between the freshwater and pulse activated. I also saw kind of stellar deformities in those that did survive. So no deformities in the no pulse condition, but then kind of between 3 and 10% of the survivors in all 3 other conditions did show some sort of deformity. That's not exceptional numbers. If you have been in a hatchery, that's a pretty standard number of deformities if you're raising thousands of fish, but because there's none in the control, we're fairly certain that's a road salt related issue. And so these are just an array of some of them. We have a normal dude in the bottom left, but some of the things that we saw were huge spinal curvatures and deformities, missing eyes, lots of missing operculums, and yolk sac edema. But because these are so varied in their presentation, to me that says it's kind of a whole system thing and it's not just one thing being affected. All right, and results from the hatch exposure, very much like Carly's work, no significant decrease in survival at hatch. These guys are obviously a little bit more tolerant and can mitigate that stress a little bit better. And so the big idea is coho survival does decrease with increasing number of pulses in that first week of development. The egg activation of water hardening is not the mechanism being affected. The continued egg swelling and egg hardening may be. Exposure to acute road salt pulses immediately after fertilization does increase deformities, but at hatch they're resilient to that stress. Of course, many people to thank for this kind of work. I'll acknowledge those folks at UBC and the land, of course. And Carly mentioned the website. We also have an Instagram that I'm trying to get up and running. We'll take any questions.
Just a question about, in the earlier part of your presentation, you were talking about like you analyzed the pulses and the peaks, and just wondering how do you like define a pulse? Like, how do you actually like separate that from low time series and?
Yeah, very carefully. It's actually kind of tricky, and there are different papers that say different ways to do it. But the way that I've done it is just taken any conductivity data that exceeds the chronic guideline, so that lowest guideline. If it increases, so the slope is positive above the chronic guideline, and it's over that limit for above an hour, then I count it as a pulse. And so it takes a little bit of finagling and R, but once you have a system going, you can forget about it. Yeah.
Thanks. Similar question about pulses, etc. Did you sort of relate the pulses to precipitation events?
Yeah, I have kind of tried to parse that apart and have precipitation data for most of the winters, actually. Interestingly, there are times when precipitation, like you can totally see it's super duper raining, and that's just pushing a bunch of salt into the streams. And then when it stops raining, the conductivity comes back down. And so it's clearly like a salting, raining combo. There are other times when they're not at all related. And to the point that you can't really correlate them. But to me, that just says it's really just the days that they're salting that is the driving factor for when we're getting these pulses. So it's hard to kind of lump in the other factors.
For the ones that you actually see a relationship between precipitation and the pulse, do you know roughly what is the lag time? That might give you an indication in terms of where the salt is coming from.
Yeah, a lot of them, it is like immediate. Yeah, the ones that I can see, it's like the curves are right on top of each other. That is something I'm playing with, is like, okay, can you relate like 3 days before or 3 days after? Can you kind of relate those things? But yeah.
I might just cut us there. Sorry,
Yeah, that's all good.
questions. Nikki just has 4 minutes to maybe.
Yeah. I know personally I also don't care if we go a few minutes over. I don't know how tight of a deadline you guys have, but these are great questions, and I like that people are getting a chance to.
I think that was an 8.
Oh, like
We just need to be like completely out of the building at 8.
Disregard.
Alternatively, I could like give my little talk, and then you guys can still ask questions to whomever you want afterwards. It's not like you're cut off afterwards.
Yeah.
I'm just like wondering how many like pulses you think that there's like on average, per week or per month from like different parts of Still Creek at least, if it's like hundreds or thousands of pulses.
Per week, I would say on the order of dozens, not necessarily in Still Creek, but that would be the high end of the scale. Some creeks it's 1 pulse per winter. Other creeks, like towards North Van, Cypress area, they aren't seeing these pulses. So it was really varied creek by creek and where you are and how much urbanization is around.
Have you guys thought about how to integrate in the amount of traffic / because Granby Highway is massive, so you mentioned the contractors, and you're sort of tracking when the contractor needs are, but I don't know how to sort of articulate it, but because I don't go Grandview all the time, but there must be lots of salting on a Grandview highway versus where some of the other creeks are. And how do you factor that in so that you can, because I think down the road when you do findings, that might go into the mitigation strategies.
You mean like how like busier highways are probably something?
Yeah, like how to deal with which creeks to deal with where there might be some more serious damage.
I'd be curious too, because on the one hand, you would think they would salt the areas where there's higher traffic, and yet the more traffic it is, it wears down the snow and the ice. So you almost like don't need as much. But I'm not a financial salting practices myself, so we have to.
But is that what they do?
But yeah, like how would you triage it exactly if you were wanting to?
Yeah, sure.
You mentioned with your data loggers that the site downstream of the highway, you saw
even compared to the site upstream of it. I was wondering if you had any information on how far downstream you're seeing those effects from your impulses.
Good question. It is kind of limited to like where the loggers are, where we can kind of figure out how far that salt plume is going, but yeah.
Yeah, we're limited in the funding to purchase the loggers because they're a couple thousand bucks each, and then the person power to maintain them because the loggers are maintained by volunteers, and so it only takes about maybe like 15-20 minutes to download the data from them, and it has to only feed in a few times a year, but it still needs to have dedicated people on each of those loggers. And so we've got like one logger in pretty much all the creeks that we monitor, and then a few of them have 2 loggers. So it would be great to have like 10, but.
Are there any data loggers in Still Creek east of, say, Boundary Highway?
May I have your attention, please? The library will close in 30 minutes.
So,
Please note all computer stations will shut down in 25 minutes.
No. Not that no, it's just those 2.
Minutes. If you wish to borrow material, please proceed to the checkout. Thank you.
A gentle nudge. Yeah, you can't make us leave.
Oh, I just want to see the map with where the 2 sites were, because I didn't totally get it.
There's that little stretch, well, where else? That's where the highest.
Oh, okay.
Yeah, Staples is the highest. The Vancouver Film Studio is not as high.
Okay,
Yeah.
because that's right beside the Brentwood Highway.
Yeah.
Yeah.
Okay, that's interesting.
Okay, so for the next couple minutes, we're going to kind of touch on just like, how can we help? What are some alternatives? And I always find personally that like conversations like this are often a little bit doomsday. I think about this for kind of any kind of conversation, whether it's climate change or ocean acidification. They often seem like such big problems that a lot of people like shut down. They're like, well, this is nothing I can do about this. So, but I think this whole project, and especially how it got started with the Stony Creek group, just a small group of dedicated volunteers, is a perfect example of one of my favorite quotes by anthropologist Margaret Mead, who says, "Never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it is the only thing that ever has." And so this project is a great example of how big changes and movements can kind of occur if you take the time to care and to try and understand a problem and work to resolve it. So it takes time and effort and patience and perseverance and a lot of arguing with your local politicians, but changes can be made. And so how can we help? So it was mentioned before that we need to use salt. It's affordable, it's for public safety. Nobody is going to go out there and say, salt is banned, we're not using salt anymore. At this point, we are still saying, please use salt, and don't go around telling people not to use salt, but the main message we're saying at this point is use less. We're trying to avoid situations like this. You only need about a tablespoon of salt per square meter, so really it's just a little sprinkling in order to be effective. Ideally, we want to apply the salt actually before it snows, so we recommend for people to kind of like keep an eye on the forecast, and when you can see that you're going to get a big snow event or the temperatures are going to dip below 0, then feel free to go out and put a little bit of salt on. If you don't catch it before the snow, just shovel first. This might seem like common knowledge for some people, but you see, a foot of snow on the ground sometimes, you see people like throwing salt on top of it. It's like, no. Like, get your exercise in, grab your shovel or something motorized if you can't shovel it, and just get rid of as much snow as possible before applying the salt. If you're not sure if temperatures are going to dip below that freezing level, this is also a great time to use sand. Like, some people worry about using sand because they think it's not going to do a good enough job. For business owners, it's often a liability concern. But if we're kind of hovering around that freezing mark and you're like, a little bit of extra traction might be good, applying a bit of sand is great. You can always sweep it up and use it again later. I haven't tested it yet, but one of the volunteers also recommended this stuff called lava grip. It's essentially just crushed up lava rock. That same idea, just adds traction. And they say it's great for driveways because you can apply it and then it adds a bunch of traction, and you sweep it up and use it the next year. So haven't tried it, but one option that is out there. Paying attention to the location of creeks and storm drains is super important. And
if you guys know anyone that deals with snow removal, we had a talk from a contractor who does snow removal, and he says that he's always very mindful, because he's also a stream keeper, of where they pile the snow after they move it around from a parking lot. Because if they pile it right on top of the storm drain, now all of the salt that may have gone elsewhere into like some green spaces is now going directly into that storm drain, and many of the storm drains go directly to creeks. Some of them do go into pipes and then they go to water treatment plants, but a lot of them go directly into creeks. And then, so if you do need to pile snow after you've shoveled it off your drive, for example, just trying to put it on areas where there's lawns, where there's a permeable surface. The green infrastructure was mentioned earlier, and green infrastructure, for anybody who's not familiar, is basically just a way of using nature to provide services. So whether things with roots and soil will absorb water and help prevent flooding. That is a green infrastructure service that they're providing. Soil will filter contaminants, including road salt, before it gets to the creeks. And so that is a green infrastructure providing service. So green infrastructure is awesome. If we could redesign every city from the ground up, I would say instead of having storm drains go directly from roads to creeks, have them go into just a patch of grass first, or a ditch, or something like that, where it can kind of settle out and filter before it makes its way to the creek. Obviously, a little bit more difficult when cities are already built, before we do all this stuff, before we're mindful of it. But green infrastructure is fantastic if you have any say in how things are developed. One thing, I don't have a slide ahead here, but one thing that is interesting to note that we learned from the contractor, and this is something where you can maybe like, make sure to go next slide for this one. I've got talking to like politicians and the people who award the contracts for salting. So many of the contracts were told the contractors are getting paid per bag of salt. So you can think how that may be problematic. So if you don't have someone saying how much they should apply or how little they should apply, and you don't have someone going out there and counting the bags of salt, they just say the temperatures get below this, go salt, and then however many bags of salt you use, charge us for it. So now you've got contractors who are encouraged to oversalt because they're not making more money from it. So writing to politicians or to Transport Canada or to any of the other agencies that award those big contracting, those big contracts, to say, hey, it would benefit you because you would spend less money on salt or snow removal, and it would benefit the environment if you just change the way you do things a little bit, count those bags of salt, suggest a certain application rate. So win-win for everybody. Otherwise, though, share what you've learned. You guys have been pumped full of a lot of information today. We don't expect you to remember everything, but there were some key takeaways. Share them with people. Talk to your friends and family about it. Let them know.
What's the encouraged brine use? What is that?
So you know when they spray liquid salt? Yeah. So that's brine. So it is still applying salt, but it's really, really diluted. And so the amount of salt that's actually hitting the roads is less. So theoretically, it means less salt making the way to the creeks.
Vancouver tries to do that. Like when they know, when the forecast sounds like it's going to get dangerous, and they find the roads, especially the hills.
I think it sticks better too.
Yeah.
I would imagine, especially on hills, the salt's kind of more rolling off on the sides.
I know they do like Central Valley Government, like half they drive it. So,
yeah, some of the municipalities, I think, are on it for various reasons, whether it's to save money or for environmental reasons, but they are on it. You know, talk to your local business managers, property managers. I lived in an apartment in Port Moody for a bit, and they just had a giant tub of salt outside with a scoop in it, so that anyone could just salt if they felt the need. But you know, having maybe a sign there saying like, we expect a little bit of salt and we would do below freezing. Just any sort of communication that way, so that people don't overuse. Yes, writing to politicians is great. When you're trying to convince people, not everyone is an environmentalist, but there's lots of other benefits of using less salt. So, first and foremost, less money spent on salt. Easy. Salt is really corrosive, so it damages concrete, it damages vehicles. So if you've got someone outside the business that is dumping it, you can kind of let them know that, hey, you're actually going to destroy the concrete outside your business here if you overuse. Damage to vegetation. So if you're a property owner and you've got like nice fancy gardens and stuff like that, and you're dumping salt on your sidewalks heavily, then you're potentially risking poisoning your own plants, and so now you've got a cost associated with that. And then one that pretty much any pet owner can relate to is that it is actually harmful for pets. So if you've got dogs that walk on heavily salted pavements, often it can like actually cause the feet to kind of crack and burn. It's very rare that they ingest enough to actually make them sick. If they're licking the salt off their paws afterwards, it can also cause them to be sick. So pick your audience and pick your argument. Okay, next slide, please. So I do want to kind of touch on this though. So people are applying salt because they care about safety. They probably have other reasons as well, but for the most part, it's a good thing. And a lot of people don't know that road salt is toxic, so they don't know that what they're doing is harmful. I often say, and I do it a little tongue in cheek because it's not a nice thing to say, most people aren't evil, they're just dumb. and so there's no malice involved when people are doing this thing. Nobody's sitting there being like, I'm so sick of these salmon, I just want to get rid of them, so I'm just going to put all this salt here and slowly kill them. Also, people are a lot more receptive to new information and are more willing to change their behaviors if they're informed kindly and calmly. So if I went up to Carly and Carly was a business owner and she was dumping salt outside her sidewalk, and I said, Carly, you idiot, like, don't you know this is toxic for salmon? Do you not care about the fish? First of all, Carly's probably not going to have me in her business anymore or be my friend anymore, but she's probably not going to be receptive to that information because she's going to get defensive. So when you share this information with people, especially if you're trying to get them to apply less salt, be kind about it. And just provide them with the information, let them soak it in. You'll find a few more. And then lastly, so this was kind of mentioned earlier, a subset of the groups that are involved in the road salt project, including the Salmon group, have come together and designed these kind of education kits that are going to be offered to elementary school teachers who teach grades 3 to 7. And these kits are essentially, they've got a series of activities that are kind of preliminary activities. Overall, the purpose of the kits is to help teachers who want to teach their students about stream ecology, the importance of like biodiversity and how things can affect that. Specifically with salmon and kind of benthic invertebrates, like the little bugs that live in the creek. But so it's preliminary activities where they kind of build context, they learn about food webs, and they're all kind of like fun games, like tag games that are modified to actually teach about biodiversity loss from stressors and stuff like that. Then they've actually got for teachers that have access to a creek, they've got field activities where they actually get to go out there and collect the bugs themselves. So they don't have the fancy equipment that the graduate students use. They've got like yogurt containers and they put some rocks in it and they swish them around and remove the rocks and count all the bugs in there. Compare whether they're bugs in like good water or bad water. The kits come with some water quality testing things, so they can go out and look at the conductivity of the water, the temperature, and then they've got some follow-up activities where they can kind of look at the data that they collected in their creek and say, okay, well, how healthy is our creek? Well, why could that be? And some kind of reflection activities that involve a little bit of art, a little bit of just like guided discussion. But so these are, I think, coming soon because like just in the final touches of it, we're going to start offering them soon. But if you know any teachers that you think would be interested in something like this, please reach out to Conley. She can put you in touch with me. They're going to be offered in a couple of different ways. One, teachers can either just purchase a kit. They're going to be about $300, and that is the exact cost it takes to just produce another kit. So the idea is that when someone buys a kit, they'll make another one, and then we can just continue to offer them. Or they can loan a kit from some of the streamkeepers that will have a kit for like $30, just keep it for 6 weeks or whatever, run the activities, get the kit back. And for teachers that don't have a budget or don't have access to a creek and don't really need the actual water quality stuff, we're just going to have all the activities available online so that they can download them, print them themselves, photocopy things. We'll have a list of all the materials that you need for each activity. So they're as available as possible for any teachers who want to use them. Or non-teachers, I mean, if people just want to do these things with their own kids and stuff like that, just fun little activities. That is it for me. Oh, it changed my emoji. That's such a cheesy one. No, that's the worst modification I get for using it for platform. I'll take it. Okay, guys. Question period. Briefly, 2 minutes.
Yeah, I was wondering, do you have kind of like a one-page or a summary of the actions people can take and why they can take it? Because I think that really is helpful when like disseminating information or just telling other people about it. When you have all your factors kind of in one for like the Instagram page, like even creating graphics about here's what you can do, and then I find they travel really well and they're more memorable because it's like 2 sentences or something like that.
We don't, but we can. Can someone help me record remember that, I'll forget.
We definitely do, like, you're good, like, there's definitely like facts and info about doing something on our website, so people will learn more about it. There'd be definitely
Turning
good
like
to
posters,
add.
like,
Yeah, you know, just add it, you make it pretty, and culture wants to read it.
yeah, I'm a big advocate of less text, more pictures.
Yeah.
We posted it on all libraries.
Yeah,
For example.
it's like telephone poles, laminated, and stick it like on, like next to the actual roads.
If hatcheries have tours for the educators, maybe, we'll mention as well.
That's a good idea, absolutely. That's our main goal for the next little bit, now that we have some data to show, because before we were like, we kind of know salt is probably bad, but we didn't have any data to back it up, so now we've got a bit of data, we're like, okay, let's move forward.
I have a question. So this is a third year of the project, or 5-year project?
Technically third year of the project, but because it got started a little bit late, just the way the funding works often takes a little bit longer, it's gonna be extended hopefully for a year, so it should theoretically wrap up summer 2028.
Are there already any talks about like even extending the project, like further than Vancouver or Metro Vancouver area?
Oh,
May I have your attention, please? The library will close in 15 minutes. Please note all computer stations will shut down in 10 minutes. The washrooms will be closed in 10 minutes. If you wish to borrow materials, please proceed to our checkout. Thank you.
On similar stuff, so it's not like we're the only ones that are looking into it, but for this project specifically, it's just a thing.
I just have a question about like the foreseeable future. Brentwood in general is developing at high rates, and I'm assuming that's adding on to such runoff because it's a concrete jungle now. Do you suspect the spikes are just going to get worse now that there's more high rises around even the Still Creek area? Like, could that lead to the extension of the project maybe?
Okay, I'm gonna answer this quickly and say that yes, more impervious surfaces is likely to increase the amount of spikes that we see.
Yeah.
But I'm gonna switch until we end a positive note by saying we're gonna spread so much awareness, and people are gonna be aware that they're only supposed to add a little bit of salt, and so that will compensate for the fact that there's less green.